Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, we are tackling the 7th question from the media examination which was written in the province of Eastern Cape in the year of 2024. Please do expect a total number of 7 videos since the question paper had 7 questions in total. That means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as well. And please guys, do help us grow the channel by just subscribing. Okay. We are told that the balanced equation below represents the first step of the ionization reaction of sulfuric acid. Nah? Okay, sulfuric acid, guys, is a diprotic acid. It ionizes in 2 steps. Are you together? So there will be a step after this, and that step will simply be HSO4 minus plus water, which will end up giving us SO4 2 minus plus H3O plus. It's diprotic, which simply means it donates a proton twice. Okay, let's answer the questions, guys. Define an acid according to the Arrhenius theory. It simply says that an acid is a substance that ionizes in a solution to produce a higher concentration of hydronium ions. Are you together? A solution that ionizes in a solution to produce a higher concentration of hydronium ions. Okay. Write down the formula of the 2 bases in the above reaction. The 2 bases in the above reaction. Firstly, let's focus on the forward reaction, guys. Né? Remember that a base is the one that is going to accept a proton, and an acid will give away a proton. Né? So sulfuric acid gave away a proton and became HSO4. Are you together? But HO2 accepted a proton to become H3O plus. So this is our base. Are you together? So I know that H2O is my base. And then secondly, now let's focus on the reverse reaction. HSO4 minus had only 1 hydrogen, but at the end it will end up having 2 hydrogens. That means HSO4 minus is also a base because it accepts a proton. So HSO4 can also accept a proton. Okay, now they want us to balance the chemical equation for the reaction between sulfuric acid and potassium hydroxide. I simply have H2SO4 plus KOH. This will end up giving us potassium sulfate plus H2O. According to Arrhenius theory, guys, whenever you try to neutralize an acid and a base, we will always form salt and water. Are you together? But let's check. The potassiums on the right hand side, we have 2 of them, but on the left hand side we only have 1. So if we place a 2 over there, that will help us with the balancing, and also a 2 over there will help us. The number of hydrogens is the same on both the left hand side and the right hand side. The number of sulfurs are the same, oxygens are the same. So this equation is balanced. And then we are told that a standard solution of sodium hydroxide is prepared by dissolving 3.812 grams to make a 100 cubic centimeter solution of sodium hydroxide. The first question, they want us to find the concentration of sodium hydroxide. I'll simply say concentration is basically equals to mass all over the relative atomic mass number multiplied by the volume. We are given the mass. The mass is just 3.812 grams. The molar mass for sodium hydroxide. For sodium, guys, I have a relative atomic mass number of 24. and then oxygen is 16, hydrogen is 1. So this will just give me a total number of no man, sodium is 23, excuse me guys, sodium is 23. So I have 24 plus 16 basically, which will just give me 40. This is just 40 grams per mole. 40 grams per mole, right? So I now know that, okay, my relative atomic mass number for sodium hydroxide is 40 grams per mole. But I'm also given the volume. If ever, guys, I'm given a volume in cubic centimeters, all I have to do is to divide it by 1,000, or you can simply say multiply it by 10 to the power negative 3. That's the same as dividing by 1,000. Yeah? And then whenever I calculate, I'll simply have 3.812 divided by the molar mass, which is 40, multiplied by, open another bracket, there's 100 times 10 to the power negative 3. So this will just give me a concentration of 0.953 moles per cubic decimeter. So the concentration of my sodium hydroxide, is basically 0.953 moles per cubic decimeter. Okay, and then now we are told that household vinegar contains X amount of ethanoic acid by mass. 25% of vinegar reacts with only 21.8 cubic centimeters of sodium hydroxide solution prepared in question 7.2.1. Okay, remember that, guys, we only had we had 100 cubic centimeters of our sodium hydroxide, né? But we only need 21.8 cubic centimeters to neutralize the acetic acid over there. Are you together? So sometimes, guys, they are not too explicit that maybe the base will completely neutralize the acid. Are you together? But they will give you a certain amount that will react fully with the acid. So I know that there's complete neutralization over here. Okay, and then the balance equation is given below. Excuse me. They want us to calculate the percentage mass of the ethanoic acid found in the vinegar if 1 cubic centimeters of household vinegar has a mass of 1 grams. Okay, the percentage mass. I want to know how much of the ethanoic acid is present in my vinegar. Are you together? How can I do so? I know that my base will only react with ethanoic acid in my household vinegar. So that means I can simply find out the amount which reacted with the base, because that would have been the ethanoic acid. Né? Okay, there are 2 ways, guys, to do this. Né? But the first way, I believe, is simple. Let's find the number of moles of our sodium hydroxide. Né? The number of moles of sodium hydroxide will simply be equal to the concentration multiplied by the volume. Remember that number of moles, guys, is N over V. Concentration rather is N over V, right? So for me to find the number of moles, I just need to cross multiply, and then N will just be C multiplied by V. So the concentration, we got 0.953 multiplied by the volume that will neutralize this ethanoic acid is just 21.8 multiplied by 10 to the power negative 3. Remember that, guys, if the volume is given in cubic centimeters, for me to convert it to cubic decimeters, I'm just going to multiply by 10 to the negative 3, or just divide by 1,000. So this will simply give me I have 0.953 multiplied by 21.8 times 10 to the power 3. What's going on? Oh. Okay, so these guys will give me the number of moles to be equal to 0.02077 0.7754 moles. Please guys, refrain from rounding off until you reach your final answer. Né? So these are the number of moles, guys, of our sodium hydroxide that will react with the ethanoic acid inside the vinegar. Okay, according to the ratio and proportion, guys, since the ratio is just 1:1 between the acid and the base, I can simply conclude that the number of moles of my ethanoic acid is basically equal to the number of moles of my sodium hydroxide, since the ratio is just 1:1, right? That's 0.020774 moles. Are you together? Therefore, I can simply find the mass of my ethanoic acid. Therefore, since number of moles is equal to mass divided by the relative atomic mass number, that means the mass will simply be number of moles multiplied by the relative atomic mass number. The relative atomic mass number, guys, is just 60 grams per mole. Né? It will be 12 plus 3 plus 12 plus 16, 16 and 8. That's 60 grams per mole. Né? So I'll take the number of moles, 0.020774 multiplied by 60. So this will just give me the mass of my ethanoic acid. That's 1.246524 grams. So therefore, the percentage of my ethanoic acid inside the household vinegar, the percentage mass is just 1.246524 divided by the total mass of the vinegar, which is 25 grams, multiplied by 100. And this will just give me, divide by 25 multiplied by 100. This will just give me 4.986%. This is the amount of ethanoic acid present inside the household vinegar. You could have found your answer like this, guys, né? Or you could have used your titration equation. Why? Because yes, they were not too direct that the base neutralizes the acid, but they told us that out of the 100 cubic centimeters we had of our base, only 28 will simply react with only 21.8 rather will simply react with the acid. Are you together? Okay, you can pause the video, guys, and write this down. Okay, let us do the second option. For option number 2, okay, I know that since my base completely neutralizes the acid, I can simply use my titration equation. I can simply say Ca Va all over Cb Vb is equal to Na over Nb. Né? I don't know the concentration of my acid, but I know that the volume is just 9.8 it's just 25 cubic centimeters, right? The concentration of my base is 0.953, and then the volume of my base, that's just 21.8. And then since the stoichiometric coefficients are 1 and 1, I'll simply write 1 over here and 1 there. So the concentration of my base will simply be 0.953 multiplied by 21.8 and then all divided by 25. This will just give me the concentration of my acid as 0.883116 moles per cubic decimeter. Okay, I can therefore find the actual mass of my acid. because concentration is equal to mass all over the relative atomic mass number times volume. Therefore, the mass of my acid is just concentration multiplied by the relative atomic mass number multiplied by the volume. The concentration is just to 0.831016 multiplied by the molar mass of ethanoic acid, that's 60 grams per mole, and then the volume that we were given, it was just 25 multiplied by 10 to the minus 3. Remember that we are changing this into decimeter cubed whenever we use this equation. So answer multiplied by 60 multiplied by 60 multiplied by 25 times 10 to the power negative 3. So the mass of our acetic acid or ethanoic acid is just 1.246524 grams. So therefore the percentage mass is basically 1.246524 all over the total mass times 100. We'll simply get 4 point something as well. 25 times 100, 4.986%. This is the actual amount of ethanoic acid present inside the household vinegar. That's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.